This is one of our myCobot Pro 600. Open the box and we can see product list, product brochure, end connector of the M8, HDMI cable, accessory screw, 2 G-clamps, emergency stop switch, power cable, power adapter, bottom plate. Finally, one of our Pro 600 robotic arms. This is one of our G-clamp. And then its roll is used to clip the inner fixed base plate. Now this piece is one of our robot arm base plate, then is fixed on the table or other platform. And then fixed with G-clamp or with screws. So here is one of our kits with screws. Mainly a backhand. And one of our base fixing screws, the end of a fixing screw. Now in my left hand is a 220 volts power input line. With this one right hand side of a power adapter. For a use. And now this one words is our emergency stop button. This side of a two-piece is received on the robot arm. And then this side words is a switch. A clockwise release, and then pressed. It is an emergency stop state. The following one is an HDMI cable. Now this one is to expand the end of the actuator. And now this one is a robot arm body. Install the G-clamp. Remove the screws. Install the robot arm to the base. Install the screws. Fix it. Connect the power adapter. The wiring process includes connecting the adapter, connecting our display. All must be connected in the case of power failure. The last step is to connect the power. Now this connector, which is the other end of the power adapter we just tried, now we have to take it and connect it to a master control of the robot arm, paying special attention to the point that this red dot should be on the tool. DC power adapter. USB. Output. E-stop. Network port. Main control power indicator. myCobot HDMI 2. myCobot HDMI 1. Type-C. I/O input. 2 I/O interfaces. Atom. Download the ROS source code from GitHub. Open ROS environment. Use ROS and slider to control the manipulator. Then we turn on the power and connect him to the monitor. The monitor has a display screen. We can see that we are in an interface, and then there is a password here. We click with the mouse. Another password location will pop up an input box. And then enter our password. Click OK and then click Login. Then we click on the Configuration Center. And on this page we can see Start Robot Arm. Shut down Robot Host. Power on. But we have to make sure that our emergency stop button is in a state where it pops up separately before we can start the robot. After the startup is complete, we can see a status of the robot on the screen. A status that shows normal. Then we click on the top left corner to return out of the menu. Click on Write a Program. Click on New Purchase Program. Then, in this purchase program we come in. There is a row of functions at the top. The first file is mainly named Save and Save As. Or Load then Edit Words is for our program. The content of the book for an edit. The tools are a quick move to control the robot. And then to view the configuration of our robot. And then to view the status of our robot. as well as the fabric of our equipment and the status of the robot. And there is also a basic setting here to control the power on and power off of the robot, as well as a setting of the load. Then the basic function is for our programming, a specific point editing, or the addition of the jaws, a setting of the waiting time. The logic function is a loop or a conditional judgment, but also not inside the programming. Then we will talk about the fast moving function. The fast moving function is used to control our robot arm. Then we can see that the angle of one joint of the robot is 90 degrees. J2 joint is negative 216 degrees. Then J3 is 126 degrees. J4 is 43 degrees. J5 is negative 90 degrees. J6 is about 0 degrees. On the left side of our interface is a DECA coordinate control, which is mainly a X direction and Y direction, Z direction movement. And then there is ASRYRZ at the bottom for controlling the attitude change. The bottom right corner of our interface shows a light, the coordinates of the current robot DCP, and a position of the pose. At the bottom of the screen, there is a move to the home position. The factory robot does not have a home position setting. It is customized by the customer, and the robot is in an upright position if it moves to 0. We can adjust the speed a little faster. This is an adjustment of speed, and then we let him move ahead. And now we can see that the robot has moved to a 0 state. The current position of a coordinate also, from just a position to 0 9900. Then we slow down a bit and click this joint in turn for rotation. Currently we can see that the joint in rotation is a J1 joint. Then the next is a J2 joint movement. Then we continue back to the origin. Then this side is a J3 joint. J4 joint. J5 joint. J6 joint.